Hi children, how are you all? Okay, nowadays you are very busy in studying your subjects. Very good. Happy to see you writing your homeworks and everything. Okay, study well. Today we are going to see about chemistry, the first unit. Okay, this is the most important subject and it is a very interesting subject. Do you like chemistry? Yes, very interesting subject. Okay, it is also full of the nature and each and everything which are happening in our body, which are happening in our day-to-day life. So chemistry plays a main role in the center of our life. In each and every product there is chemistry. In eating food, our dresses also, all are made up of atoms and molecules. So chemistry is everywhere. Okay, in your classroom, if you watch, in the chalk piece, in the table, in the bench, the dresses you are wearing, okay, in your home, everywhere there is a chemistry. Okay, chemistry is full of atoms and molecules. Okay, in biology, how DNA, RNA plays an important role for human beings, like that in chemistry, atoms and molecules are the most important basic fundamental. Okay, do you understand children? So chemistry is very important and interesting subject. Okay, now today we are going to see about metallurgy. Okay, we are going to see about metallurgy. It is a very interesting topic. Okay, listen carefully. Let's start. Now, what is metallurgy? Do you have any idea about metallurgy? The science of joining metals by welding. The science of joining metals by welding is closely relates to the field of metallurgy. Joining the metals, joining different metals, combining different metals, that is included in the field of metallurgy. Okay, metallurgy involves science of, see here, the most important 5 points are given. Producing metals from ores. Okay, ores, from ores they are producing metals, and for making alloys, for metal reactions, for heat treatment, for steel making, okay, processing of metals, forging, foundry, etc. Do you understand children? So metallurgy involves in these fields. So producing metals, joining metals, making new alloys, okay, like that. So welding metallurgy is also there. It can be considered as a special branch. Okay, welding metallurgy is a special branch since reaction times are very small, while in other branches reactions are large. Welding metallurgy, the reaction times are very fast. Okay, it deals with the interaction of different metals. This welding metallurgy deals with the interaction of different metals and interaction of metals with gases and chemicals. Do you understand children? It deals with the interaction of different metals, and also interaction of metals with gases and chemicals. Metals with gases and chemicals. Do we understood? Right. Now, see the picture. See the picture, metallurgy. Okay. The full process of metallurgy is explained in this picture. The full process of metallurgy is explained in this picture. See, minerals, ores, and from the ores, concentration of ores. By concentrating the ores into 4 process: gravity separation method, froth flotation method, magnetic separation method, leaching method. Leaching is further classified into cyanide leaching, acid leaching, alkali leaching. Okay, and then extraction of crude metal, and then conversion of ore into oxides. There 2 process involves: roasting, calcination. Further, reduction of metal oxide. Further 3 process happens: melting, reduction, auto reduction. Further, refining process. Okay, further refining process, finally they get pure metal. Do you understood children? In metallurgy, what we are doing, okay, what we are doing means it relates to the science and technology of metals. Metallurgy relates to the science and technology of metals. Okay, in nature only few metals occur in their native states. Okay, ஒரு சில metals தான் Native means sondam. Okay. So some metals only will be in native states. All other metals are in combined states as their oxides, sulfides, silicates. Okay. Some metals such as gold, silver, okay, platinum, okay, these are native in state. These are native in state. This is not combined with any other. They are in a single way. Okay, they are in their native state. But other metals will combined state, combined with their oxides, sulfides, like that they are combined. So the extraction of pure metals from their natural sources is linked to the history of human civilization. Okay. So ancient people used the available materials in the environment, which includes fire and metals, and they were limited to the metals available on the earth's surface. Okay. In the modern world, we use a wide range of metals in our everyday life, isn't it? In your everyday life, you are using different types of metals now. Okay, that is result of development of metallurgical knowledge over thousands of years. Okay, our need for the materials with specific properties have led to the production of many metal alloys. So it is essential to design an eco-friendly metallurgical process, okay, to maximize energy efficiency. So such advances in metallurgy are going on nowadays. Okay, do you understood what is metallurgy? The extraction of pure metal. Extraction of pure metal. புரியுதா? நிறைய கனிம தாதுகள் அதெல்லாம் எப்படி இருக்கும் அப்படின்னா இம்பியூர் ஃபார்மில் இருக்கும், கம்பைன்டு ஸ்டேட்டில் இருக்கும், 2-3 மெட்டல்ஸ் கலந்து இருக்கும். புரியுதா? அழுக்கு, மண், ஸோ சம் இம்ப்யூரிட்டிஸ் இதெல்லாம் கலந்துருக்கும். அப்படி இருக்கக்கூடிய மினரல்ஸாக இருக்கட்டும், ஓர்ஸாக இருக்கட்டும், அதை என்ன பண்ணுறாங்க, கான்சென்ட்ரேட் பண்ணுறாங்க. கான்சென்ட்ரேட் பண்ணுறதுக்கு ஒரு 4 ப்ராசஸ் இருக்குது. ஃபர்தராக எக்ஸ்ட்ராக்ஷன் பண்ணுறாங்க. அது எக்ஸ்ட்ராக்ஷன் பண்ணி ஒரு மெட்டல் உருவாக்குறாங்க. அதிலிருந்து சம் ஆக்சைட்ஸை கன்வெர்ட் பண்ணி ஃபர்தராக மெட்டல் ஆக்சைடு அதை ரிடக்ஷன் பண்ணுறாங்க. திரும்ப என்ன நடக்குது, ரிஃபைனிங் ப்ராசஸ். அதில் டிஸ்டிலேஷன், லிக்வேஷன், ஜோன் ரிஃபைனிங், வேப்பர் ஃபேஸ் மெத்தட், லைக் தேட் தேர் ஆர் டிஃப்ரெண்ட் மெத்தட். ஸோ இந்த 4 விதத்தில் ரிஃபைன் பண்ணுறாங்க. ரிஃபைன் பண்ணதுக்கு அப்புறம் தான் கடைசியில் என்ன கிடைக்குது, பியூர் மெட்டல். ஃபைனலி we are getting a pure metal. Okay, do you understood? Finally we are getting a pure metal. Okay, that is like aluminum, copper, zinc. Okay, they are not get easily. Okay, we get it by these process. Okay, see the process in metallurgy, these much process are doing. Finally only we are getting the pure metal. Okay, in this method, in your home you are drinking water in a steel tumbler. Is it easily you get in the tumbler? No. There are many process which is made to a tumbler. Okay, lot and lot of process are behind that tumbler. Okay, do you understood? Right. Okay. Okay, what is metallurgy? It is a science of extraction of metals from their ores and their purification. Metallurgy is a, tell with me, metallurgy is a science of extraction of metals from their ores and their purification. Okay. What are minerals? Minerals are naturally occurring substances. They are containing elements or compounds. They are containing elements, compounds, okay, molecules, atoms filled with elements, compounds. These are becoming minerals. Okay, they are naturally occurring substances. Naturally occurring substances are minerals. They are found under the earth. Okay, what is ore? Ore is a mineral from which one or more metals can be extracted. Okay, one or more metals can be extracted, that is ore. Okay, next, what is metallurgical process? The process used to get a pure metal, that is the metallurgical process. Okay, it consists of 3 steps. Okay, first of all, concentration of ore. Concentration of ore. Second one, reduction. Third one, refining. Okay, right. What is concentration of ore? Removal of impurities. What is concentration? Concentration of ore means removal of impurities. Do you understood? Concentration of ore means removing the impurities from the ore. Okay, and what is reduction? It is the process of obtaining metal from its compound. Reduction means the process of obtaining metal from its compound. And what is refining? Refining is the process of purification. Of impure metals. Process of purification of impure metals to obtain the pure metal. Process of purification of impure metals to obtain pure metal. Have you understood, children? Right. Now, occurrence of metals. Okay, in general, pure metals are very shiny and malleable. Okay, pure metals are shiny. Shiny means palapalappu thanmai. Okay, that is shiny. Malleable means easy to the shape which you are making. Okay, that is. However, most of them are found in the nature as compounds. Most of them are found in nature as compounds with different properties. They are having different properties. Okay, metals having least chemical reactivity. Metals having least chemical reactivity such as copper, silver, gold and platinum. Metals having least chemical reactivity such as copper, silver, gold, platinum occur in a significant amount. They are native elements. Okay, I already told that. What is a native element? Gold, silver, platinum. See the yellow color box, AuPtAg. Okay, they are very precious metals, passive, noble, very precious. They are found in the free state. Free state means native state. Okay, and reactive metals such as alkali metals. Reactive metals such as alkali metals usually occur in a combined state. Okay, and are extracted using suitable metallurgical process. So, for extracting the combined state metals, we are using the metallurgical process. Okay, high active metals are found, medium active metals are found. Okay, what are high active metals? They are found in the salt types. Okay, chloride. Okay, NaCl. Okay, sulfate, carbonate, silicate, phosphate. Okay, high active metals are found in the salt format. Chloride, sulfite, carbonate, silicate, phosphate. Okay, see the example KCl, NaCl, NaNO3, KNO3. Okay, what is KCl? Potassium chloride, sodium nitrate, potassium nitrate, calcium sulfate, magnesium sulfite. Okay, like that. Calcium carbonate, magnesium carbonate. Okay, like that. The salts type are high active metals, they are found. Okay, next medium active metals. Okay, medium active metals are found in the oxides and sulfide types. Medium active metals are found in the oxides and sulfide types. Their example is given. Okay, ferric oxide, zinc oxide. Okay, zinc sulfide, lead sulfide, copper sulfide, like that. And gold, platinum, silver are native state, and these are found in the others are found in the combined state. See here, list of some metals and their common ores with their chemical formula is given here. Okay, what is the first one? Aluminium. Aluminium is a metal. Okay, aluminium is a metal. How this metal is got? By the ore. Ore is the first one. Mineral and ore are the basic, fundamental, and from that ore only, by doing the purification process, finally we will get the aluminium. Finally we will get the metal. So the ores are bauxite, diaspore, kaolinite. Okay, these three are the ores, and by purifying the ores we will get aluminium. Okay, the ores formula is given, composition. Okay, Al2O3 NH2O, diaspore Al2O3 H2O, kaolinite Al2Si2O3 OH4, like that. Okay, from these ores we can purify and derive aluminium. And next, iron. Iron is a metal. It is got up from the ores like hematite, magnetite, siderite, iron pyrite, limonite. These are the ores of iron. Okay, you should study this tabular column. Okay, you should know the ores and the metals. What are the ores of iron? If you may be asked what are the ores of iron, you have to write hematite, magnetite, siderite, iron pyrite, limonite. Okay, in one word question also you can write this one. Okay, and ores of copper, copper pyrite, copper glans, cuprite, malachite, azurite. These are the ores of copper. Next, ores of zinc, zinc blende, calamine, zincite. Okay, and ores of lead is galena, anglesite, cerussite, like that. And for tin, that is tin stone, cassiterite. Okay, and for silver, silver glans, ruby silver, horn silver, stephanite, proustitite. Okay, these are the ores and metals and their composition. Now, what is the difference between mineral and ore? You may have a doubt, what is ore and what is mineral? Okay, naturally occurring substance. Okay, naturally occurring substance obtained by mining. Okay, mining, do you know mining? What is mining? Naturally occurring substance. To find the naturally occurring substance, okay, there is this, that process is called mining. Okay, in that process we find a metal in a free state or in the form of compounds like oxides and sulfides. That is called a mineral. That is called a mineral. Okay, in most of the minerals the metal of interest is present only in small amount. Some of them contains a reasonable percentage of metal. Okay, for example, iron is present in around 800 minerals. However, some of them such as hematite, magnetite, etc. containing high percent of iron are commonly used for the extraction of iron. Such minerals that contain high percent of metal from which it can be extracted conveniently and economically are called ores. Okay, right. What is mineral? Naturally occurring substances present in the earth crust. Naturally occurring substances present in the earth crust. Okay, what is the ore? Minerals which can be used to obtain the metal profitably. Minerals which can be used to obtain metal are called ores. All minerals are not ores, but all ores are minerals. Okay, all minerals are not ores, but all ores are minerals. See the example, clay is the mineral of aluminium. Clay is the mineral of aluminium. Bauxite and cryolite are the main ores of aluminium. Okay, ores of aluminium, bauxite and cryolite. But clay is the mineral of aluminium. Have you understood, children? Right. See here, here is a picture which will explain you. Now, first of all, there is a ore. The brown color is ore, okay, and the ore is purified. Okay, purified. How the purification is happening? The metal compounds are separated from the bits of sands and rocks. Like that, they are purifying it, and metal compound is extracted. Metal compound is extracted. Further extraction is going on. What is extraction? Metals are chemically separated. Metals are chemically separated from other element. So, by doing chemical reactions for separating, finally we will get a metal. In this way, ore is converted to metal. Now, concentration of ores. Okay, concentration of ores. Okay, the extraction of metal consists of three metallurgical processes. The main three metallurgical processes are: first one, concentration of ore; second one, extraction of crude metal. Already you have seen in the table, one table tree representation. Okay, first diagram I have taught you that metallurgy and mineral, ore, and the three process: concentration of ore, extraction of crude metal, refining of crude metal. Okay, let's see one by one. First of all, concentration of ores. Concentration of ore. Today we are going to see deeply about concentration of ores. Okay, what are the processes going on in concentration of ores? How the impurities are removed? What is concentration of ores? Removing the impurities. I already told you, concentration of ore means removing the impurities. Have you understood, children? Concentration of ore means removing the impurities. Three main concept in metallurgy is: first of all, tell with me, concentration of ores. Concentration of ores. Second one, extraction of crude metal. Extraction of crude metal. Third one, refining of crude metal. Refining of crude metal. Last we will get the pure metal. Okay, the first step, concentration of ores. What is concentration of ores? Removal of unwanted materials. Removal of unwanted materials. What are the unwanted materials? That is sand, clays, okay, small stones, pebbles, like that. They are unwanted materials. Okay, for removing those unwanted materials from the ore, okay, we are using concentration. That is known as concentration. Removal of unwanted materials such as sand, clays, etc. They are called concentration of ore. Okay, do you understood? It involves several steps, and selection of these steps depend upon different physical properties of the metal. Based upon the physical properties of metal and that of the gangue, we are doing several steps. Okay, it is based upon the physical properties of the metal. And the type of the metal, available facilities, environmental factors are also taken as consideration. Okay, before doing a process, we have to think about the environmental factors and the physical properties of the materials, that minerals, etc. Okay. Generally, ores are associated with non-metallic impurities such as rocky materials, siliceous matter. Okay, that is called gangue. What is a gangue? It is a impurity. Gangue is a impurity. It is a rocky material, siliceous matter, non-metallic impurities. Okay, collectively known as gangue. Okay, the preliminary step in metallurgical process is removal of that impurities. So, removal of gangue or removal of impurities. That removal process is called concentration. So, it increases the concentration of metal of interest of its compound. It increases the concentration of metal. So, several methods are available for this process. Okay, based upon the choice of the method, it will depend upon the nature of the ore, type of impurity and environmental factors. Okay, some of the common methods of ore concentrations are given below. I will tell you. Okay, see here the methods of concentration. First of all, gravity separation method. Gravity separation method. Write down, children, the methods of concentration. Methods of concentration of ore. Gravity separation, the first method, and the second one, froth flotation, and the third one, leaching, and the fourth one, magnetic separation. Have you written? First, gravity separation. Okay, gravity separation. Okay, in this method, the ore having high specific gravity is separated from the gangue. Gangue is the impurity. Okay, dust particles. Okay, ore which is having high specific gravity is separated from the gangue that has low specific gravity by simple washing with running water. Okay, this gravity separation is done by hydraulic washing. Okay, ore is crushed to a finely powdered form and is treated rapidly with flowing current of water. During this process, the lighter gangue particles are washed away by the running water. This method is generally applied to the concentrate native ore such as gold and oxides such as hematite, tinstone, etc. Okay. The gravity separation involves feeding grounded ore into a pulsating body of water which serves to settle out the heavy material while floating away the tight material. Okay. Do you understood? See the picture. There is a hydraulic classifier. In that hydraulic classifier, the ore is crushed. Okay, ore is crushed to a finely powdered form. See, it is coming outside. Okay, heavy ore is coming outside, and the water is coming. Okay, in a flush way. Okay, water is also coming. Okay. Right. Now, it involves the feeding grounded ore into the pulsating body of water which serves to settle out the heavy material while floating away the light material. So, heavy material will be safe and the light material will go away. So, if the heavy material is what you wish to keep, then it is taken from the bottom. If you wish the light material to keep, then it is taken from the top. Okay? Do you understood? The ore which is having high specific gravity is separated from the gangue that has low specific gravity. Okay? Ore which is having high specific gravity. Okay, gangue la irundhu high specific gravity irukkudiya ore separate pandrom, low specific gravity irukkudiya ore separate pandrom by simply washing with running water. Okay, washing with running water. Okay, இந்த process நடக்கும்போது அந்த lighter gangue particles la wash away ஆயிரும். Okay, lighter gangue particles are washed away by the running water and heavier gangue particles will be safe. Okay, example, gold and oxides such hematite, tinstone, etc. These are having high specific gravity. So, high specific gravity particles are kept and low specific gravity are washed away. So, in this way the separation is happen. So, hydraulic washing is used. That process is called hydraulic washing. Now, froth flotation. This method is commonly used to concentrate sulfide ores such as galena, zinc blende. Okay, galena, zinc blende, they are the ores of lead. and zinc, okay, ore of lead and zinc, okay, concentrate sulfide ores, okay. In this method, the metallic ore particles which are preferentially wetted by oil can be separated from the gangue, okay. Do you understood? In this method, most of the minerals do not pass enough floatability, and it is difficult to float these minerals without aid of chemical agents. So, in order to achieve satisfactory separation of valuable minerals from gangue various, flotation reactions such as classified collector, frothers and modifiers are used, okay, for achieve satisfactory separation, okay. So, for achieving better separation, flotation process is used, okay. See, this is the froth flotation process. There is a motor and gap for air supply, controller, feeding place, there is a stirrer, there is a valve, there is a sensor, there is a tailing, okay. Now, let me tell you what happens. In this method, crushed ore is suspended in water and mixed with frothing agent, okay, such as pine oil, eucalyptus oil, etc. Okay, we are taking crushed ore. Ore என்ன பண்றோம்? Crush பண்றோம் in suspended water. Okay, crushing, and we are placing it in a suspended water and mixing with the frothing agent. What is the frothing agent used in this process? Oil, pine oil, otherwise eucalyptus oil. Okay, now we are taking a small quantity of sodium ethyl xanthate, which is act as a collector, okay. And a froth is generated by blowing air through this mixture, okay. A froth is generated by blowing air through this mixture. The collector molecules attach to the ore particle and make them water repellent. So, as a result, ore particles wetted by the oil rise to the surface along the froth. So, now the froth is skimmed off and dried to recover the concentrated ore. The gangue particles that are preferentially wetted by water settle at the bottom. The gangue particles are wetted by water that will settle at the bottom. So, when sulfide ore of metal of interest contain other metals such as sulfide, impurities, depressing agents such as sodium cyanide, sodium carbonate are used to selectively prevent other metal sulfide from coming to froth. For example, when impurities such as ZNS is present in galena is added to depress the floating property of Zn by forming a layer, okay. Do you understood? In this method, what you are taking? We are taking a crushed ore, okay. We are taking a ore and the ore is crushed thoroughly, okay. The ore is crushed thoroughly, which is suspended in the water, and it is feed, okay. It is feed into the feeder, and the motor is on and the stirrer is rotating, okay. Now, we are adding a small quantity of sodium ethyl xanthate, okay, which is act as a collector, okay. Now, the froth is generated by the blowing air. By blowing air supply, we are giving the air supply, and now it is generated through this mixture. The collector molecules attach to the ore particle and make them water repellent. So, as a result, ore particles are wetted by the oil which rise to the surface along with the froth. The froth is skimmed off and dried to recover the concentrated ore. Now, the gangue particles are come to the bottom. Gangue particles come to the bottom. So, if there is any dust particles, okay, any impurities, in hydraulic washing we are removing the impurities. Some impurities may come again also. So, that impurities, for removing that impurities, we are doing this froth flotation process. Now, the gangue particles are settled at the bottom. Now, what is leaching? Okay, what is leaching? This method is based upon the solubility of the ore in a suitable solvent and the reactions in aqueous solution. Okay. In this method, the crushed ore is allowed to dissolve in a suitable solvent. Okay. Now, you are taking the crushed ore and you are dissolving in a solvent. Okay. The metal present in the ore is converted to a soluble salt. Okay. While the gangue remain insoluble. Now, you can separate the gangue. By seeing the soluble nature, okay. The gangue will not be soluble, okay. It is insoluble in nature, okay. Then you will remove the gangue. Do you understood? Right. Now, there are types of leaching, okay. Cyanide leaching. First one is cyanide leaching, okay. Consider the concentration of gold as an example, okay. You are taking gold and you are removing the impurities from the gold. You are removing the impurities from the gold. What are you doing? You are crushing the ore of gold. You are crushing the crushing the ore of gold, which is leached with aerated dilute solution of sodium cyanide. Okay, leached with aerated dilute solution of sodium cyanide. Okay, you are using a agent here, leaching agent, that is a cyanide, sodium cyanide. So leaching done by a cyanide solution is cyanide leaching. Okay, the crushed ore is leached with dilute solution of sodium cyanide. Now the gold is converted into a soluble cyanide complex. Now the gold is converted into a soluble cyanide complex. Okay, do you understood? Now the gangue aluminosilicate remains insoluble. Do you understood? The gold is converted into a cyanide complex. Now the gangue will be remain insoluble. The gangue is aluminosilicate that remain insoluble. Adu mattu soluble ஆகாது, தனியா soluble ஆகாம இருக்கும். Okay, see the equation. Gold, the symbol for gold is Au. It is in a solid state. So 4 amount of gold in the solid stage plus 8 number of Cn, that is cyanide. It is in aqueous solution. It is in aqueous solution. Okay, we are taking a crushed gold. It is in a solid form. Now we are taking a dilute solution of sodium cyanide. So dilute solution, that is in a aqueous form. Okay, and you are taking oxygen, which is in a gaseous form. Okay, oxygen is in a gaseous form, and you are mixing with water. Water is in a liquid form. Okay, what you have taken? Gold, which is in solid form, cyanide, which is in aqueous form, and oxygen, which is in gaseous form, and water, which is in liquid form. Okay, you are mixing with it. Now what happens? It becomes 4 of gold cyanide. Okay, gold cyanide, it is in aqueous form, and plus 4 hydroxide. So the aluminosilicate will remain insoluble. Okay, the gold is converted into a cyanide complex. Gold is converted into a cyanide complex. Now recovery of metal of interest from the complex by reduction. Recovery of metal of interest from the complex by reduction. What happens here? The gold can be recovered by reacting with deoxygenated leached solution. See the equation. Zinc gets reacted with deoxygenated leached solution with zinc. Okay, that sodium cyanide complex, no, AuCN twice, that is in aqueous form in the previous equation, that is get reacted with zinc. Okay, now gold is reduced to elemental state, that is zero oxidation state. That process is called cementation. Now zinc is taken in a solid form, and the cyanide complex of gold is taken in aqueous form. Both got reacted and given zinc cyanide. Okay, zinc cyanide 4 and gold. Okay, gold is separated. That process is called cementation, in which the gold is reduced to a zero oxidation state. Now ammonia leaching. Okay, in ammonia leaching, the crushed ore which is containing nickel, copper and cobalt, that is treated with aqueous ammonia. Under suitable pressure. Okay, under suitable pressure it will form the complexes. See the picture, NiNH3 6 power 2 plus, like that. Okay, see the 4 elements are given. Okay, these are the nickel, copper and cobalt complex. Nickel, copper, cobalt complexes. Okay, from the ore leaving behind the gangue. Okay, iron oxides, hydroxide, aluminosilicate, these 4 compounds are left over. This is the ammonia leaching. Next, alkali leaching. Okay, alkali leaching. In this method, the ore is treated with aqueous alkali. In this method, it is treated with alkali, that's all. In previous, it is treated with ammonia. In previous, that is treated with cyanide, like that. So, alkali leaching means the ore is treated with aqueous alkali to form a complex. Okay. For example, bauxite is an ore of aluminium. Okay. Bauxite is a ore of aluminium which is heated with the solution of sodium hydroxide at a certain temperature 470 to 520 Kelvin at a pressure, atmospheric pressure 35, to form a soluble sodium meta-aluminate which is leaving behind the impurities iron oxide and titanium oxide. Okay. See the equation, Al2O3, okay, aluminium oxide plus sodium oxide plus water, which gives sodium aluminium hydrous in aqueous solution. Okay. This is the alkali leaching. Acid leaching, okay, leaching of sulfide ores such as zinc blende, okay, zinc blende and lead, okay, can be treated by hot aqueous sulfuric acid. Okay, zinc blende ZnS is treated with H2SO4 sulfuric acid plus water in a gaseous form. It gets zinc sulfate plus sulfur plus water. Okay, in this process insoluble sulfide is converted to a soluble sulfate. Okay, insoluble sulfide is converted into a sulfate, soluble sulfate and elemental sulfur. So, leaching of sulfide ores can be treated with this sulfuric acid. This is called acid leaching. Next, magnetic separation. Magnetic separation, okay. This is another separation method. In concentration of ore, we are seeing 4 methods. Say the first one. What is the first method? Gravity separation. And the second one, froth flotation. And the third one, leaching. And the fourth one is magnetic separation, okay. In this method, it is applicable to ferromagnetic ores. Okay, this method is applicable to ferromagnetic ores and it is based on the difference in the magnetic properties of the ore. It is based upon the magnetic properties of the ore and the impurities. It is based upon the magnetic properties of the ores and the impurities. For example, tin stone can be separated from the wolframite impurities, which is magnetic. Similarly, ores such as chromite, pyrolusite having magnetic property can be removed from the non-magnetic siliceous impurities. Okay, the crushed ore is poured into the electromagnetic separator. Okay, do you understood? For example, tin stone. Okay, tin stone. Okay, it is a ore of tin. Okay, then it can be separated from wolframite impurities, okay, which is magnetic. Okay, wolframite impurities which is a magnetic. Okay, right. Now what happens here? In this method, the impurities are taken by the magnetic properties. Okay, see the picture, you will understand it clearly. There is a funnel like shape, no? That is the place where you have to put the ore and it will crushed and come out as a powdered ore. There are 2 magnetic wheels and a pulley, a moving belt. Okay, pulley that is like a, which is used in a rice mill also, this structure, no? Have you seen? In wells also, while catching up the water also, there is a pulley. So, like that, there are 2 magnetic wheel with a moving belt and on magnetic ore and a non-magnetic ore. How the magnetic separation happens? Let me tell you. The crushed ore is poured to an electromagnetic separator. What is the electromagnetic separator? The magnetic wheel with the moving belt, no? That structure is the electromagnetic separator, which is consists of a belt moving, over the 2 rollers. There are 2 rollers and above the 2 rollers there is a belt. Okay, one is magnetic, one is non-magnetic. Okay, the magnetic part of the ore is attracted towards the magnet and falls as a heap close to the magnetic region, while non-magnetic particles fall away. Okay, magnetic ores are collected in a magnetic ore, non-magnetic particles are collected in the non-magnetic. In this way, the magnetic parts are separated. Do you understood? Magnetic properties or magnetic materials are get separated by this magnetic ore and non-magnetic ore. The crushed ore, the powdered ore is poured onto a electromagnetic separator which is having a belt moving over the 2 rollers, which one is magnetic, the magnetic part is attached to the magnet and falls as a heap close to the magnetic region. And magnetic ore comes up here and non-magnetic goes away. Okay, this is the magnetic separation. In this way, the impurities are separated. First of all, it is separated by gravity separation method, second by froth flotation, and further by leaching process, and further by magnetic separation. In this 4 method, the impurities are separated. Impurities are separated. This is the first heading, isn't it? Concentration of ore. Concentration of ore is completed. Further classes we will see about second one, extraction of crude metal. Okay. Today this much. Now it's time for your homework. Okay. Do you understood, children? All the things do you understood? Right. Good. Now you have to write 10 one words from the topic. Okay. From the topic, from the starting to magnetic separation I have completed, and from the starting to up to magnetic separation you have to write 10 one words. Okay. From the table column also you have to write what is the ore of this and this metal, which is the ore, like that also you can make one words. Okay. And difference between minerals and ores. Okay. You have to write the difference between minerals and ores with examples also. And you have to write the methods of ore concentration. There are 3 methods. You have to write there are 3 methods, and you have to explain the first method. You have to explain the first method. Okay. 10 one words you write in your homework, and rest 2 questions you make it as an assignment. Okay. Methods of ore concentration, you write the 3 headings and you have to explain the first one. Okay, children. That's all. This is your homework today. Okay, children. Thank you. Have a nice day.